A couple of kind of bonehead things I wrote on the board here. It said Vy was 1/2 3 meters per second squared times t squared, and Vx is 0.8 meters per second. Now this is actually right, but what I really intended to write was that your y position is 1/2 of 0.3 meters per second squared times t squared, and your x position could be 0.8 meters per second times t. Now this relates to the problem with the boat drifting to the west at 0.8 meters per second, and then accelerating to the north at 0.3 meters per second squared. If the initial position is 0 and the initial instant at which the acceleration began is 0, t equals 0, then these are the equations of your two positions. You're going to move at a constant 0.8 meters per second squared in the x direction. And actually it might be negative 0.8 if we're considering west to be the negative x direction and north to be the positive y direction. Then we would have these two equations, or these two position functions, and our path, which is what we were talking about. So when I wrote V's up here, that was just pretty ignorant. Our path is easily enough found, okay? Our x-coordinate, well, if this is our x-coordinate, then t equals negative s sub x over 0.8 meters per second. So sy is 1/2 of 0.3 meters per second squared times t squared, which equals 0.15 meters per second squared times negative 5x over 0.8 meters per second. And I've got x, I've been using sx, negative 5 s sub x over 0.8 meters per second squared. Well, if you work this out, 5 over 0.8 is 6 1/4, 6.25. And if you square that, you get about 30. And you multiply that by 0.15, you get about 4.5. The units are second squared over meters. This is not a meter per second squared. Those units wouldn't have worked out. There's a meter per second. So now the units are reciprocal meters. Reciprocal meters times sx squared. Yeah, that works. Okay. Sx will be in meters, so sx squared will be in meters squared. Multiplied by reciprocal meters gives us meters, and those will be the units of sy. Now, if I just use x and y instead of sx and sy, this becomes y, if y is the position in the y direction, equals 4.5 reciprocal meters times x squared. That's up y equals a constant times x squared. That's a parabola, okay? So we have a parabolic y versus x. A parabolic path. We also talked about what happens to the direction. Okay, if our initial direction is to the west, when we start accelerating, then we start building velocity to the north, which means the direction of our velocity will swing around toward north. But it'll never be exactly north. It'll never be exactly north because we've always got that 0.8 meters per second time to the west. So we're going to approach the northern direction, but asymptotically. So our swing around toward north will be, our direction will change more and more and more slowly. Okay, so every second we can calculate our velocities in the x and y directions. After 1 second, initially 0.8 meters per second that way. After 1 second, we have 0.3 meters per second that way. So our velocity will have a 0.3 meter per second and a 0.8 meter per second component in that direction, giving us the velocity in this direction. After another second, we're going to have 0.6 meters per second in this direction, still negative 0.8 meters per second here. That's going to swing us around again, but not quite as much as the first one. And you can work that out mathematically, the properties of the sine and the cosine. But right now we just want the intuitive idea of an object moving at constant velocity in one direction and uniformly accelerating in another. That always gives us one position as a multiple of t. The other position will be quadratic in t. Since this is linear in t, it's going to be linear in the x-coordinate. And since this is then quadratic in t, this position will be quadratic in x. So we'll always have a parabolic path. Maybe not as simple as this one, but it's always parabolic because a graph of a quadratic function is always parabolic.